Hello friends, Hamjammer here and this is Rusty Beats, a new channel about vintage computers. In the pilot episode we will build and test the replica of my first PC, KT Technology Personal System AT. So let's get to it. I got interested in the vintage computers a few years ago. I knew right away that I would like to build the replica of my first PC. I had several original parts from it, but finding the other stuff was a bit of a challenge. However, today I can finally get to work on this project. The computer was manufactured in 1990 or 91. I got it in August 1995 and I had it for 2 years. Beside the VHS clip from 1996, which you can see right now, I don't have any photos of it and I forgot some details. Fortunately, there was no problems with the technical specification. I got this computer along with the dot matrix printer, which I used to print anything I could with the print screen button. Prints included the checked screenshots or the hard drive directory tree. I found these printouts while preparing the episode. Along with the prints, there was also a drawing of my computer which I made probably in 1996. I drew the computer's case and the send on UPS quite accurately. I also sketched the floppy drives. I never had a CD-ROM in this computer, although it is on the drawing. SVGA monochrome monitor, made by TVS, was bought in May 1996. Of course, there are also some peripheral devices. And this is the excellent Epson FX 1050 9-pin dot matrix printer. On this BIOS setup printout we can see the BIOS version, RAM capacity and the port addresses. Here we can see the checked printout with more details, like a DOS version which came with the computer. After a system failure which I caused in the late 1995, I replaced DOS with the most recent version. Computer still had a single hard drive back then. Detailed information about the system resources and the TSR programs which were in use can be seen on these printouts. And here is the configuration summary from another diagnostic program. CPU installed in this PC was 286 16MHz, which from what I remember was made by AMD. Also a configuration which I wrote down myself. As you can see, MDA and CGA graphic cards make use of different memory addresses. This information will be useful in a minute. I also documented the Seagate ST-157A and ST-351AX which I had in this computer. Furthermore, I found an original build sheet with which one of the hard disks was delivered from the factory in 1991. I had a hard time remembering the machine's brand. I knew, however, how the logo looked like. I asked at the Wagons forum, but nobody helped me there. Fortunately, I found help on the Polish 3DFX forum, where I got the answer the same day I posted the question. Callahan, who is one of the most experienced people I know when it comes to vintage PCs, referred me to a page with computer's photos. The link in the response led to the pc-history.com, where I found the exact pictures of a computer like mine, including the motherboard and the case. Let's say a few words about the KT Technology PTE LTD. Company was established in 1987 in Singapore. According to sgpbusiness.com portal, KT's main activity was retail sales of computer hardware including handheld computers, peripheral devices, computer software excluding games and cybersecurity solutions, but also wholesale of lifts, escalators and air conditioning equipment as secondary activity. Company went bankrupt in 1997, which led to liquidation of its subsidiaries worldwide, which is confirmed in at least 2 independent sources. Its main sales markets were probably Australia and Oceania, the Far East and Central and Eastern Europe. I draw this conclusion on the basis of the location where I found the KT equipment and traces of the activities of its subsidiaries. Look at this hardware presented by Ronin82 and Quicknick at the Vogons forum, both users from Romania. Or these computers owned by Betmojo from Australia. I suspect that the company, apart from selling, was also a producer of computer systems and peripherals, like this early model of a portable hard drive, which description I found on the internet, or expansion cards that you will see in a moment. Although the company also had a Polish branch and quite often you can find computer components marked with its characteristic logo, it's still a bit of a mystery to me. With this information I was able to start searching for the components needed to build the replica. The first thing I managed to get was a motherboard equipped with 12 MHz 286 Intel processor and the Headland G2 chipset. Motherboard works under the control of quite rare Quadtel BIOS programmed in 2 EEPROM chips. 1 MB of RAM in deep chips will be replaced with SIP modules like I had in my computer. Fortunately, leaking battery didn't cause too much damage. The motherboard is not equipped with an FPU, but in this case we don't need one. Most of the settings are configured with deep switches. Designation on the board is 12/0HT101A286. This is a fairly common model of 286 motherboard, although it usually comes with the popular AMI BIOS and other ISA bus connector configurations. It's not exactly the same model I had, but it's very similar. And this is another specimen from my collection, with AMI BIOS and AMD CPU. Total Hardware 99 refers to this motherboard as Baby 286. I will install not one, but 2 graphic adapters in this computer. The first one is Hercules Clone from KT Technology, exactly as it was in my 286. The second one is the Trident 9000. It's the original card from my 90s machine. I have an original user's manual for it. The warranty card was also preserved. The card was purchased in May 1996 together with the SVGA 14-inch monochrome monitor. I bought it from the emitter company in Warsaw. Trident 9000 is quite underrated, but they are pretty much the best cards for 286 and 386 builds. They have excellent compatibility with previous standards, which can be said for example about Senk ET4000, and they work without problems in the 8-bit mode too. This particular card has 9000i chip and half megabyte of memory. The computer must have an IDE controller and multi-IO card. This typical floppy drive and IDE hard drive controller will fit this build nicely. Its serial number also begins with KT letters, although it's probably Kentech computer product. By accident I found another Hercules Clone card in the box with the controllers. Probably also a KT Technology or Kentech product. In my 286 I used Covox digital analog converter at first, but the Sound Blaster 2.0 was quickly introduced when I bought it from my classmate. Nobody doubts that the Sound Blaster is the original PC sound standard, Creative Labs must have felt threatened by the increasing competition, however, if they decided to put this intrusive slogan on the packaging. Along with the card, we received a large software package. The card has 11 voice FM synthesizer, allows you to play and record PCM sound, is equipped with MIDI interface, a joystick port, and so on. It was one of the first sound cards that offered such a rich feature set. Let's take a look inside the package. As many as 8 double-density floppies with drivers and additional software. Colorful instruction for the Lemmings game. Indianapolis 500 game manual. Registration card. Information how to obtain the software on a different media format. Supplementary worksheet for using Indianapolis 500. Supplement to the sound card's user guide. Comprehensive card user guide. And text-to-speech user guide. In addition, we have a TRS to RCA cable. And finally, of course, the card itself. We will look at it in a moment. Every inch of the box is filled with the specifications and marketing information. This is hardly ever seen today. The card itself is an early revision too. The changes between subsequent revisions were minor and have no effect on how the card sounds. In case of this particular card, I installed the replica of the CMS chips, which adds Game Blaster compatibility to it. Here for a comparison is a later revision 6. As I said, the changes are cosmetic. As a mass storage, I will install a Seagate ST-157A hard drive. These drives were the pinnacle of Seagate's hard drives with servo-driven heads and are very reliable and durable. Additionally, they sound great. As you can see, I have quite a lot of them. According to the specification, I should use Seagate ST-351AX as the secondary drive. I still have the original drive from my 90s machine. A in the symbol stands for ATA interface, while X for XDA. This drive supports both of these standards. These disks are quite rare, in high demand, and their prices are crazy. In practice, this hard drive will be much more useful in a computer that requires an XDA drive, like this Commodore PC-23 or 10D1000TL. So instead I will use more recent, larger Seagate ST-157A. Another option worth considering would be the compact flash card adapter, like this one, or this one in housing I designed. Probably I will use it in the future for the sake of practicality. I also still have the original floppy drives from that PC. The 3.5-inch drive is the unique Canon MD3621. Unfortunately, it stopped working some time ago and I couldn't fix it. The 5.25-inch drive fell victim to an unsuccessful retrobright a few years ago, but we will fix it in a moment. It is a Canon drive as well, model MD5501. Some time ago I found another one on eBay, but it is very yellowed. I still have a Logitech Mouseman, which I used back in the 90s. Today we can only buy GPUs or motherboards in boxes of this size. The documentation itself is very extensive too, and includes a Logitech product catalog, a quick installation guide, a comprehensive user guide, and the mouseware floppy disks. I repaired the mouse recently by replacing the DB9 connector, at which the cord broke in the 90s. I also have another mouse which I used after the Mouseman broke down. But it's cheap, low quality mouse that I definitely won't use anymore. This keyboard is identical to the one I used with my 286. The micro switch buttons make it enjoyable to use. It supports both XT and AT standard and was manufactured by NTC. Last, but definitely not least, is the computer case. I looked for it for 2 years, and finally it was found by my friend. The front panel has typical elements like keylock, reset button, turbo switch, and LED indicators. This embossing on the front panel is a characteristic feature. Another characteristic feature are those plastic white buttons used to lift the top cover. Power switch is located on the side of the case. The emblem was missing when I bought the case. The original emblem was donated to me by Bedmojo from the Vogons forum. Big thanks to you, brother. Inside you will find a typical layout. Unfortunately, there is no frame for mounting 3.5-inch drives. We will fix that in a moment. A typical L-shaped 200-watt PSU is inside. I remember very much enjoying these warnings in multiple languages. On the back there is another KT Technology logo along with the computer's serial number. I have another KT Technology case. I think this one will be perfect for building a Turbo XT class computer. Inside, both cases are identical. A few minutes of playing around with the caliper and watching photos, and I designed the missing frame in 3D. It's time to unleash the plastic melting monster. The printout will take several hours. In the meantime, let's do something about the look of 5.25-inch drives. I will paint the discolored one in the original color. To choose it, I use the RAL color palette chart. Time to dismantle the station. Removing the lever requires pushing out the retainer pin. Before painting, let's once again compare the colors. This time I use paper strips, which I have sprayed with the paints I have. The elements should be degreased. I use IPA because acetone would dissolve the ABS plastic. The paint has to be shaked well. Shake it, baby. We use painting tape to mask the elements. Instead of paper tape, I prefer vinyl one. It provides better adhesion and is a bit flexible. We apply the paint in many thin layers, leaving each one of them to dry before applying the next one, to prevent the stains. We will bleach the yellow drive in around 12% hydrogen peroxide solution. 35% hydrogen peroxide is a very aggressive substance. To avoid splashing it on your clothes or skin, remember to always pour it into the water and not the other way around. We will use a piece of wire so that the element doesn't float to the surface. Let's place the container with the element in the sun. Heat is more important here than the UV radiation. Every 15 or 20 minutes we check the progress and remove the oxygen bubbles accumulating on the element. In the meantime, it is worth carrying out a routine maintenance of drives by applying a thin layer of silicone or Teflon grease to the mechanical parts. You can also clean the heads with isopropyl alcohol. Drive panels are ready. The retrobrighted one has a perfect shade to match the case. I will use the second one, painted in the original color, in another project. Meanwhile, the 3D printer has finished its work. And here is a finished 3.5-inch drive frame. It looks a bit like a medieval building. We start assembling the computer. The first thing is to check the board for a potential short circuits. Thanks to this, we will avoid fireworks from exploding tantalum capacitors. Everything looks okay. My 286 had 2 MB of RAM, but we will equip this motherboard using 4 MB in SIP memory modules. This is a bit too much for a 286 machine, however, I don't want to split this set of identical Intel modules. First, we need to pull out the memory in the DIP chips. The board doesn't support configuration with SIP modules and DIP chips installed simultaneously. Modules should be installed so that the first pin of the module connects to the first pin of the socket. Both are marked. Another thing is to configure the amount of installed memory using DIP switches. We do this according to the instructions from the Total Hardware 99. With this processor speed and the speed of memory chips, we can successfully set the board to the zero wait state mode for better performance. The last jumper is used to set the parity check and is set correctly. For sustaining the CMOS memory, I will use, how else, the nickel-cadmium battery. I am always amused by the fear of using them some people have. Properly used good quality battery won't damage the motherboard and will serve for many years. And the battery is soldered in. We always test old power supplies before connecting the electronics. The test should be performed under sufficient load, like an older hard drive for example. Sometimes 2 or more drives may be required. Let's see what happens when the power supply is not properly loaded. After connecting only one disk, it could be concluded that the power supply is out of order. Instead of 5 volts, we have 3. Instead of 12 volts, less than 5. The disk and the power supply fan won't even start. The situation looks much better with 2 disks. There is almost 10 volts on the 12 volts rail and exactly 5 volts on the 5 volts rail. The motherboard is mounted in the case using those horrible plastic standoffs. As always, you need to connect the cables from the keylock, turbo and reset buttons and LED indicators. We will install this multi-IO card in my computer. Jumpers allow you to select addresses and port interrupts. This card has everything neatly described, although it doesn't feature a game port, as we don't need one. We mount IDE controller and graphics card. Before connecting the hard drives, the jumpers should be set appropriately. Jumper settings are still available on the Seagate's website. And this is how drives look like in a 3D printed frame. The first hard drive will be mounted in the 5¼ bay using adapters like this. As I mentioned, the original 3.5-inch floppy drive doesn't work anymore. However, we still need a drive like this. So I will use this Chinon drive in the adapter, and the original Canon drive will remain unconnected. We will mount the 5¼ inch floppy drive in the upper bay. As usual, we connect the hard disks and the floppy drives with the ribbon cables. Finally, we mount the power supply, making sure that the P8 and P9 motherboard connectors are oriented with the black wires facing inside. Because, as the folk wisdom says, red to red and you're dead. The power supply doesn't have Berg connectors for connecting 3.5-inch floppy drives. The solution is an adapter like this, connected to the standard large AMP connector. After connecting the power supply, we are ready to power up the machine for the first time. And it works! Let's take a look at the setup program right away. The Quadtel BIOS setup is dated 1989. Compared to what American Megatrends or Award offered at this time, it looks more modern. In the main menu, we have a choice of options such as General BIOS settings, Extended properties, System information, the possibility of password protection, and options useful with older MFM RLL drives. In the General settings, we find what we would expect: real-time clock and memory configuration, floppy drives and hard drive settings. We won't find any options regarding LIM AMS memory, because the Headland G2 chipset doesn't support it without additional GC103 chip, which this motherboard doesn't have. The extended features lets you enable automatic parking of the MFM and RLL hard drives, a quick power on self-test, a screensaver in the text mode, and keyboard options including speed and sound. The system information shows port configuration, BIOS version, amount of installed memory, and the type of processor and coprocessor. After the initial configuration, we can start installing the DOS and copying a few programs useful for further tests. My cat tells us that we need to boot the system from a boot floppy. As you can see, I already created drive partitions and formatted them in the past, so we don't have to do this. It's just a matter of transferring the operating system. I will copy the most necessary programs to the util directory using Volkov Commander, which is a lightweight clone of the Norton Commander. By the way, let's see how the PSU performs when it's properly loaded. I wonder how many of you would scrap it after the first no-load test, or even when it was loaded with only a single hard drive. As you can see, the voltages are perfect. The last thing for today is to add a second graphics card and a sound card. Using NSSI, let's check if they are visible in the system. As you can see, the Sound Blaster and both graphic cards are properly detected by the program. Both serial and parallel ports and a game port are also detected. And that would be all for today. I hope you enjoyed this episode. In the next episode, we will test this PC. I will install several games and programs I used in the 90s. See you soon. Bye.